let's study the points of differences between scalar quantities and vector quantities. What are the differences? The major difference is scalars don't show direction, means no direction. This is a major difference. This is a defining difference. You can say vectors don't show direction. Scalars show direction. Vectors. Scalars no direction, vectors show direction. Okay. Another point, a scalar quantity is always positive. Vector quantity can be positive or negative also. Okay. Vector can be positive or negative. For example, we can say suppose it is distance equals to, it will always be positive 5 km. Distance will always be written as plus 5 km. Never it can be written minus 5 km. But here it is displacement, we know it is a vector quantity. Displacement can be minus 5 km. Okay, or it can be plus 5 km. This minus will show it is in the opposite direction. Only it will show the direction. Minus means opposite direction. Okay, so it can be positive or negative, and it is always positive. Okay, third, it is one dimensional. It is one dimensional. It is multi-dimensional. Multi-dimensional means can be one dimensional, can be two dimensional, can be three dimensional. Okay, in this way. It means what does it mean? It means let us see here. It is distance 5 km, means it is 5 km and no direction. It means it is one dimensional, simply a scalar like simple algebra. And this is multi-dimensional if it is said that 5 kilometer northeast. Okay, northeast. It means what? This is north, this is south, this is east, this is west. Okay, this is northeast 5 kilometers, means in this direction. Okay, this is northeast. This is what? This is on x-axis also, this is on y-axis, this is in the middle of that. If any point we will consider here, it will have projection here also, on x-axis also, and on y-axis also. Okay, so it is two-dimensional here. This is a vector. We know this is a vector. 5 km northeast is a vector because it has magnitude. Yes, 5 km. It has direction northeast. Yes, it is a vector. Magnitude and direction both, and its representation we can say it is two-dimensional. Okay, it is not on a single coordinate, it is using two coordinates, so it is two-dimensional here. So it can be, vectors can be multi-dimensional. Okay, now next point of difference is in algebra. It follows simple normal algebra. Okay, normal rules of algebra are applied. Normal rules of algebra. In scalars, normal rules of algebra are applied, and in vector quantities, it has a different algebra. It has its own algebra which is called vector algebra. It means we see addition, subtraction, we use some different rules, that is triangle rule, parallelogram rules. Then there is a different category of algebra. It follows vector algebra and it follows normal rules of algebra. For example, we can say if we have to add 5 meters plus 5 meters, nothing to think, it is 10 meters. Without thinking, we can say it is 10 meters. But here, if it is 5 meter east plus 10 meter north, we will consider a different algebra. Okay, we will need to plot the graph. Where is 5 meter east, where is 10 meter north, and this, then after we will take the point, there is a different thing. Okay, this algebra is called vector algebra. We will study it later, but we should remember the point of difference, that is it follows vector algebra. It is following simple rules of algebra which we studied up till, that is simply simple algebra. Okay, next point is examples of scalars. Examples of a scalar: mass, length, distance. These are examples of scalars. Okay, we can say some more. Work also is a scalar quantity, and here it is for vectors. The examples are displacement, force, acceleration. Let's see, what does it mean? Example, in example we saw force, we saw acceleration. It means they will follow all the characteristics of vector quantities. That is, their algebra will be different. They can be multidimensional. They can be positive, negative. This all things will be in these things. Okay, thank you.